So last time I did a code review, I talked about how there was a resource manager that was written that wasn't quite right, that wasn't quite how I would write a resource manager, and I gave a lot of like tips and ideas and just opinions really on how I would go about doing something like this. And what I thought I would try out today is a bit of a new format. We're gonna expand on that a lot more. We're gonna do a bit of programming here together, and I'm gonna actually show you what I mean rather than just talking. Got my coffee, I'm wearing my cozy sweater. There is even a lit candle in front of me. It's raining outside, which you probably can't hear. So let's just chill out and do some programming together. Okay, so here is the code that we're gonna be looking at today. If you wanna see the full code review that I did, it was kind of more of a part one, but anyway, I'll have it linked up there. This is what we're going to discuss in a bit more detail and also probably rewrite. So first and foremost, let's kind of do a bit of a more thorough review of this specific class, and we'll go into the details of why I think it needs work. So first of all, let's just have a look at this entire file. So it's a file called resourcesmanager.h. It's got a whole bunch of different errors that are implemented as a subclass of this error resources manager that is a runtime error. So the author of this code obviously loves exceptions. I personally am not as big of a fan of exceptions in a language like C++. However, that's not what this video is about, so let's just ignore that. By the way, if you guys do want to check out like the context of this code for yourselves and actually see the project on GitHub, I will leave a link in the description below. So looking at the header file of this specific class, we get a pretty decent idea of its public API, which usually helps us understand how a class is actually used. However, what I like to do, even more so, is actually have a look at how this code is actually used in the rest of the code base. This gives us a pretty decent look of everything that's possible with this API. However, it doesn't really give us a practical look at how it's used within the context of this project. So if we take a look at the main file, for example, which is right over here, then you can see, and by the way, I did actually end up modifying this code a little bit from the original code in that code review video, but this is the context of how it's initially used. This resource manager, we get the instance of it and we call .load, which takes us over here into this function where we explicitly load these kind of strings which refer to file paths of textures, sounds, and fonts that we want to load. And then if we go to something like the menu file over here, then you can see that we reference those assets that we loaded, such as this menu.png. We do that by just calling a resource manager instance and then get texture. So that is really surprisingly like the gist of this entire class. It just gives us a way to initially just like kind of blanket statement, just load everything that needs to be loaded, which obviously is specific to this particular project. And that effectively preloads all of the assets that we need from disk. And then what that enables us to do is anywhere in our code base, just reference that kind of global instance of the resource manager, the singleton, and just call get texture or get font or get whatever to actually retrieve the asset that we want to use. So that in and of itself gives us a pretty decent idea of what this class is actually used for, as well as how it functions. So let's then talk about the specific issues that I have with this, as well as what we can do to actually improve the resource manager. So first and foremost, I don't like the fact that the resource manager is the actual body of code that does the specific loading of specific resources that are relevant to this project. I see the resource manager as more or less like a system that has an implementation that is treated like a black box. It's not something that you're supposed to be able to look into the implementation of or even have to modify the implementation of to get what you want out of it. That's a little bit weird. So ideally, what we want when using this resource manager is we have the resource manager over here, and then we have our code base over here. This line separates our code being like, hey, I want to load this specific like PNG file or whatever from the system that actually does the loading. So this is like the internal loading. And then this is simply a way for us to call into that code and tell it what to do. It will then store it presumably in some kind of data structure. And then we can request it by calling get. And then the resource manager somehow will like fetch it and deliver it to us. So notice how the actual files that we're trying to load, the assets that we're handling, which is kind of like user code, it's our code, is different from the code that is the system. This means that the user of this system never has to actually look into the system to find out how it works. Why is this an advantage? Honestly, lots of reasons, but the biggest advantage is that you don't have to understand any of this. You certainly don't have to modify the resource manager system. That's kind of above your pay grade, and it provides one of the best features of software development, reusability. You've created this generic piece of code that can be applied to lots and lots of different use cases. And I would probably go as far as to say that software development at its core is the balance between writing kind of generic code that can be reused easily, but balancing that with writing specific code that perfectly fits your given use case. Because leaning too far into either generic reusable code or specific code usually results in a suboptimal solution. Now, for those of you just getting started with your computer science journey, I have the perfect thing for you. A 30-day free trial, Brilliant.org, the sponsor of this video. For those of you who don't know what Brilliant is, it's an amazing website filled with lots and lots of really high quality courses on various STEM topics. As I mentioned, if you're just getting started with computer science, or maybe you know a friend who's trying to get into programming, I think Brilliant.org is one of the best places to get your start because they have these really high quality, engaging, interactive courses that start off extremely gently and actually teach you how to think like a programmer. You won't just be sitting back and watching videos that you can zone out of. Instead, you'll actually be interacting with the teaching material, dragging all of these things around, for example, to set the flow of this program, and being constantly quizzed to make sure that you're actually retaining this information and learning properly. But it doesn't just stop at computer science. Brilliant's math courses are amazing. The thing about teaching math that I think is so important is that you teach it visually, which is why I think Brilliant is just such a great fit for this, all the way down to their everyday math course and through to more advanced topics like linear algebra and calculus. They have this beautiful visual interactive teaching style the whole way through, which in my experience not only makes the learning fun, but also drastically helps with you actually retaining the information that you've learned. And as I mentioned, you can get started for free. Just go to brilliant.org/the link will be in the description below, where you can get a 30-day free trial to check out all of the courses that Brilliant have to offer on their platform. Huge thank you as always to Brilliant.org for sponsoring this video. So going back to the balance that I was just talking about, as we talk about ways that we could improve this system, I think it's important to realize that there's a certain trade-off of the complexity of the system really that is to be desired, because this at the end of the day is a very simple project, it's a very simple game. There's no real engine to this either. If you have a look at this over here, the game and the engine, like the game and the core systems, are kind of linked together. I mean, you can really see that they're linked together because again, the resource manager literally explicitly lists everything it loads. We've got like random facts over here. We've got regions and coordinates and airports, and everything is included within this resource manager, which again, I would definitely change that design, but that's just the nature of this. This is not supposed to necessarily be some kind of reusable framework. And I think that one mistake that can happen a lot with software development is that people don't understand sometimes that things are meant to be simple. There's no need to overcomplicate certain things if you're never going to reach that scale where it matters. Instead, all you're doing is wasting your time potentially, unless you enjoy it. If you're doing it for fun, obviously knock yourselves out, but you're going to be potentially wasting your time as well as overcomplicating the code, which is going to make it harder to deal with for both you and other developers. So because of that, we're not going to approach this the same way that I would for Hazel, for example. Instead, I'm going to try and find that balance. And so the first thing that I think we can hopefully all agree on is that this just shouldn't be here. And so as I'm doing this, in the back of my mind, probably the front of my mind, the thing that I'm keeping track of here is simplicity. I'm trying to make sure that this ends up being possibly even more simple than it is right now. So let's take a look at the structure of this, because one of the first things that stood out to me is the fact that this is a singleton, right? We have a deleted copy constructor, an assignment operator, we have a private constructor, and we have this static instance that we can see first of all gets initialized basically the first time we call it, and then it just persists forever. So I don't really like both that lifetime model, but also the concept of using singletons in this way in C++. And the reason why is C++ simply does not need singletons. In languages like Java and C#, you have no way really around writing this kind of singleton setup because everything is a class. Everything has to be a class. In C++, you can just do that, for example. And this obviously is outside of any kind of class. It's just sitting here in global space. We're limiting the scope to just this file, this translation unit, by using the static keyword. But other than that, it's just suddenly global now. That obviously achieves the exact same thing as this. However, it gives us some additional flexibility with lifetime. Not this specific way that I've written this, but I think that the lifetime of a resource manager might be important. The reason why is because these resources need to get unloaded somehow. And I think that that's something that people don't really think about. And to be fair, I'm a little bit on the line here. I'm a little bit on the fence as to how important that actually is. The reason why is because this, again, is a small game. There is not going to be any kind of resource unloading during gameplay, as far as I'm aware of. I don't think that's necessary. So then the only reason we'd be unloading them, releasing these, is at the very end of the application when we close the application. But that brings in the argument of, well, do we need to unload them if we're just terminating the application? The answer technically is, well, no, because the operating system will automatically clean up all the memory, obviously, when we terminate this application. It just gets reclaimed like that. It's much, much, much faster than us going through and actually freeing each resource and visiting all of these, clearing the memory, doing everything. We're like tidying up after ourselves. And then the operating system's like, yeah, you didn't really have to do that. I'm just going to clean everything up. It's kind of like if we were, I don't know, demolishing a house and we went in and we just cleaned all the floors and we just made sure that everything was sparkly clean. And then we're like, all right, now you can wreck it. Now you can take the house down. That's just like, why? Why would you clean the floors if you're about to demolish the entire house? Yes, it might be better and it might be all clean and nice and like, yay, but functionally there's no difference. And in fact, what you've done is you've just wasted time. However, shutting down like an instance of a graphics API like Vulkan, for example, it really shouldn't be done until you actually free all of the resources that you've allocated through that API on the GPU. And if you don't do that, it'll yell at you. So there could be potentially reasons for freeing resources. I think the biggest reason to do it is probably not for this use case, but almost just because it's a bit of a habit. So to give you a real world example, when I was making Hazel, the first time I set everything up and I had like a project being loaded in the editor, I could like go around, load all the assets, I could build my game, build my world, whatever. I had that up and running, everything was fine. And I didn't really need to rely on any kind of system to unload these assets because that was it. It was just that one kind of project, that one scene. We could build it up, you could hit play or whatever. And at the end of the day, it just ends with you hitting the close button and closing the application. But then we added more scenes. We added more projects. You had like a project, a game that you were working on, and then you could be like file open and open a different project entirely. So then what happens to that old project and all the assets and the resources that were associated with it? Well, because we had no mechanism to unload assets at all, they kind of just live on. They kind of just stay there because we didn't really have that facility to clean up after ourselves. And I think at the end of the day, that's what it comes down to. If that was quote unquote properly designed from the very beginning, then we would just have that just naturally. It would naturally be able to be like, okay, you switch projects, these assets, they're tied to the lifetime of this project instance. So therefore, when the project instance dies, all of the assets get taken with it because I'm doing stuff correctly. I'm making sure that my lifetimes are tied to actually like parents, I guess, that encompass their lifetime, such as, for example, a project with a bunch of assets. The assets shouldn't just be global, shouldn't just be in a singleton. They should be relative to that project, so that when the project dies, all of the assets die. If I had just designed it from that way in the beginning, then when I expanded and when I scaled and I had suddenly more than one project, everything would just work just like that with zero effort from my part, with zero thinking about like, I should redesign this. I don't have to do any of that because it's kind of properly designed from the beginning. And I think that that's, again, at the end of the day, that's what this comes down to. It's the fact that like, it's not really much effort for us to make sure that we are thinking about these things, and it's a really good habit to get into, and it means that future development is likely going to be just a bit more flexible and a bit easier. And again, the biggest argument to this is, yeah, but I'm not going to do any more future development. This is all the game needs to do. And to be fair, that is potentially hard to argue with, but I think what it might come down to, it's kind of like an artist just making sure that their work is up to a particular standard. As a programmer, you are somewhat of an artist. You're an artist engineering this masterpiece. And as a C++ artist, I think one of the most important things that you always think about is memory and thus lifetime of resources. Okay, so with that being said, let's move on because I feel like I'm maybe getting a little bit too deep. I don't know. This is, as I mentioned, a new format. Let me know what you guys think in the comments section below. Am I going into a bit too much detail? I don't know. Okay, so first and foremost, let's talk about how we're going to be handling the lifetime of this particular object. So as we know, the object has all of this data associated with it. When should that data be initialized and when should it be deinitialized or freed or killed or whatever? The simplest way I think to handle this in this specific project is going to be probably just going to be to stick it into the main function, to be completely honest. The reason why is because that's where it initially lived and there is no application class. I might initialize this in the application class if there was one. You know, in larger systems, you might actually have a specific project, as I mentioned, that the resources belong to. So then when you load that project, when you initialize the systems related to that project, that's probably where you would initialize that resource manager. And then when the project gets killed, when the project dies, that's when you deinitialize like all the systems associated with it, like the asset system, like this resource manager. So I'm trying to kind of keep this the same. This, by the way, was from the code review. This wasn't originally here, but it's a bit of a similar idea to what I would have. So what I'm going to do is I'm going to have a resource manager. It's going to be a pointer and I'm going to call it G resource manager. Now you don't have to use this G underscore prefix. I like using this for global things. You also don't necessarily have to store this within this file, but you will need access to it in some way. So what I could do, this might be a little bit better actually, is I'm gonna cut this, or actually copy this, and put it into the resource manager implementation file. So that way, this resource manager is going to basically have a pointer to the only living instance of itself. So what I've done over here is very similar to the singleton way, and we're gonna use it in a very similar way. It's just subtly different, but this subtle difference is gonna come with all of the benefits. So the first thing I'm gonna do is I'm just gonna make this null pointer. But there's a few things that are important about this. First of all, you can see it's not tied to any particular scope, right? This is just a global variable at the moment. It's present in this one single place. It's a pointer and it's set to null pointer. That's all it is at this point in time. We obviously want to be able to use this though outside of this class. So what I'm going to do is I'm going to go to this resource manager, and somewhere here, doesn't really matter where, I'm just going to add in, let's maybe come down after we declare the class, and we'll say extern resource manager G resource manager. The reason why I'm adding this into this header file is because I want this to be present basically everywhere where it's included. And because this is marked as extern, when this gets included into a file such as main, so by including that header file, we're obviously including this code, it means that it's not going to create a new variable called G resource manager, because that would be obviously weird. We'd have a different pointer in each file that wouldn't be set to anything. It's just going to reference that existing one. If this was a function, we would simply have like the function prototype with no body, and that would be fine in the header file, but because this is a variable, we have to use this keyword here. Another way you can technically do this is you can actually go into this header file and just have inline resources manager, G resource manager, and then you can set it to something like null pointer. I think possibly these days I might prefer that. The reason why is because it means that if you go over here, you don't need to have this. It's effectively a global variable, but it's just in a header file, which means that you don't need to have it actually defined in the CPP file. You can just have this single mention of it in the header file, and that's it. And then when it gets included, it won't be like a new variable, right? So if I make this global like that, that's not going to work, because everywhere where I include resource manager, it's going to be its own version of that G resource manager variable, which isn't going to work because they're global variables. It'll be like, hey man, you already have this variable defined. You can't define another variable with the same name. That's not going to work. Static, same situation. It's going to mean that each translation unit has a unique copy of G resource manager, but then inline comes in to save the day, because it means that there's only going to be one copy of this throughout the whole application. So actually, I think I would rather solve it this way. Now, if we go down over here into instance, we want to be able to potentially use this through this instance API. Why? Well, potentially two benefits. It might look a little bit nicer than referencing G resource manager directly, even though we can, but also note that this is a pointer because I want to specifically create an instance of it at a particular point in time, but this is a reference. So if we just return G resource manager and then dereference it, it means that we don't then have to later dereference that pointer or use the arrow operator to access its members. We can just call dot. And also by keeping this function, I'm actually making it compatible with the rest of the usage of this class throughout this code base. So from the point of view of this API, nothing's changed because that instance function is still there. I've just kind of changed the underlying implementation of how that singleton is created and just made it like a global, really, more than a singleton. So then over here in main, that is where I want to initialize this. I'm going to call G resource manager equals new resource manager, like that. This at the moment is private, so we have quite a lot of options, really. We could make this public. We could probably make the main function a friend function if we wanted to. I don't think I've ever done that before. So if we did like friend int main, oh, that feels weird, doesn't it? I've never done that in my life. Let's go back and see if this even works. Control F7 to compile that. And yep, okay, I am a mad scientist. I don't know if I would do that. You know, what this would do is just limit it to the main function, right? So if I had another function here, anywhere else, this is not gonna work. It's gonna tell us that it's private. However, because this is the main function, we're allowed to access it there. It's probably not the worst thing in the world. Again, I wouldn't have this in the main function to begin with. I'm just adapting this to the rest of the current code. I'd probably have this in some kind of application or project initialization function to begin with. That's where I would initialize the resource manager. The other thing you could do, because I don't think I'm going to do that at the end of the day, to kind of stop this or at least make it a little bit better, is you could make a static function here called create, which assigns to that, or call it init. That's just going to make it, I think, a little bit cleaner, and it's going to handle that implementation. The reason why is because you might not know that to initialize the resource manager, you have to just create a new heap allocated instance like this. And then what if that allocation coming from the heap with the new keyword, what if that strategy changes? So what you could do instead is have like a static void init, and then if we just create a definition for this, what this could do is just do G resource manager equals new resource manager, or obviously within the resource manager class. So this can remain as private like that. And then from main, this looks a little bit neater as well, because we go from this code to just that, which I think is cleaner, right? So what that does is it creates the instance. Now we obviously want to shut it down. That was part of the whole reason we even had this. So let's go over here and I'm gonna call resource manager shutdown, which doesn't exist yet. We're gonna go back to resource manager to init. I'm gonna duplicate this, make a function called shutdown. And then if we create this, that's just gonna call delete G resource manager. And then I'm gonna set resource manager to null pointer. Why? Because just on the off chance that we try and use it later, it's gonna be nice if we run into a null pointer rather than a random memory address. Because what happens is if we delete this, sure, it's deleted the resource manager, it's freed that memory, but what is resource manager? It's a variable that's a pointer. And what is a pointer? An integer. I have a whole video where I say that like 50 times. I'll have it linked up there, pointers in C++. I think that's over 1 million views now, which is crazy. Classic Cherno back in the day. But anyway, the point is, it's just a number. So obviously if resource manager is set to, this, for example, just because you've deleted what's at that address, you haven't actually changed this number to 0, right? And that's what this code does over here. And again, the only reason to do this, if you're shutting down, usually you don't care. Like if this was a member variable, I wouldn't set it to null pointer because the whole class is dying. But because this is a global variable that we can theoretically access anywhere else, it just means that we won't accidentally access it potentially. And if we do, we'll easily see that, oh, it's null. It doesn't exist. It either hasn't been initialized or it has already been shut down. And you could even, into instance where we retrieve it, because obviously this will crash, you're dereferencing a null pointer. You could even have some kind of assert where you just make sure that, this is not null, basically, kind of like that. Okay, wonderful. So we have init, we have shut down, and if we go back to main, we can see that we have very clearly defined this lifetime. Now I've written this in a bit of like a heap memory version where we have init be an actual pointer that we allocate on the heap here. There's quite a lot of stuff going on here, and because this is like a core system, I probably would have it be a heap allocated system, but you don't technically have to. We could have also used RAII with just resource manager to actually allocate it here. So we could have had our resource manager instance here, had some facility to retrieve it. It becomes a little bit murky in my opinion, even though it's technically possible. So what you could do, and this is going to be a little bit wild, but if you did want to perhaps automate this init and shutdown so that you don't forget to shut it down, you could almost treat this kind of like a scoped pointer or a unique pointer. This is why this series, I think this new format is fun, because I can just go into random thoughts like this. So hopefully you guys are enjoying it. So if we just had like a struct here called system, what I'm going to do is inside the constructor, I'm just going to call t init, right? So all this is a wrapper that just will call init and shut down for us. And then inside here, I'm just going to call shutdown. And so with this very simple kind of class, I was going to call it class as struct. It's basically a class though, right? Instead of doing init and shutdown, what we can do is just do system resource manager, and then I don't know, RM if we wanted to. And then we don't need shutdown. But since we have this nice scope here, we could, again, use RAII if we wanted to make sure that we didn't forget to shut it down. Would I do this? Probably not. I just think it's like a lot clearer if you just have resource manager init and shutdown. There's also no ambiguity as to when it gets destroyed, like in what order. If you had a few different systems and they had to be shut down in a particular order, then I would prefer this. It's much more clear. All right, so I suppose we should test this code base. I don't know if it will compile if I've left stuff in it, but let's just test this to make sure that it basically still works the same, because I've obviously modified the lifetime, so we can't access private variable. Yeah, this I just forgot to delete. So let's try and run this again. All right, there's our game. Let's do Iceland, and there we go. I mean, I guess that works. Seems like it works. Okay, so this video just ended up being about the specific lifetime and the singleton and how to kind of rewrite it into something a little bit better. Do you agree with the changes I've made? Does it make sense why this is potentially better? Do you think it's worse? That's okay. Let me know in the comment section below. Now that we've handled the lifetime, which again, I think is the most important, one of the most important things just in programming in C++ in general, but specifically for something like a resource manager, very, very vital. Now that we've handled this, next time we're gonna move on to actually, hopefully, like rewriting the rest of this resource manager. I hope you guys enjoyed this video. Let me know what you thought of the new format. Don't forget to hit the like button if you did enjoy it, and I will see you next time. Goodbye.